In this lesson, we're going to look at radical equations, so equations that have radicals in them, and how to solve and simplify them. So steps for solving radical equations. We're going to always start by isolating the square root sign, the square root. Let me get my pen here. There we go. So always isolate the square root. So get that whatever square root expression by itself. Anything that's not under the square root needs to go to the other side of your equation. Once you've done that, you're going to square both sides to undo the square root. And finally, just solve for your variable that's left. So here's our first example. We're going to start by isolating the square root. So here we have the square root of x plus 3 equals 9. So this plus 3 needs to come to the other side to get just the radical by itself on the left side. So to take something to the other side of your equation, you undo its operation. So we subtract 3 from both sides. This leaves us with the square root of x equal to 6. At this point, step 2 is to square both sides. So I will square that one to undo the square root and square the right. Whatever you do to one side, you must do to the other to maintain the equality. So the square root of x squared will just be x, and 6 squared will be 36. So x's value is 36. And you can check this by replacing x with 36. So the square root of 36 plus 3 should equal 9. So 6 plus 3 equals 9. We are good. All right, try this one on your own. So isolate your radical and then solve for your variable. When you're ready to check it, click pause and then click play. All right, so to isolate the radical, you should subtract 5 from both sides, leaving you with the square root of x equal to 9. Then square both sides, leaving us with x equal to 9 squared, which is 81. Here's our next example. So step 1 is always to isolate your radical. Well, in this case, the radical expression is the only thing on that side of the equation, so it is fully isolated. So we actually can skip over step 1 and move straight to step 2, which says to square both sides. Anytime you square a square root, it leaves you with just whatever was under the square root sign, so the radicand. So the square root of 3x plus 4 squared reduces to just 3x plus 4, and 7 squared is 49. In step 3, we actually have a little more work to do to isolate for x and solve for x, so you'll subtract 4 from both sides, and then divide both sides by 3 to get x to be 15. All right, so as I mentioned briefly, you should always check to make sure the solution works because you will sometimes get solutions that do not work. And so let's take a look at what that would look like. So here's another radical equation. We'll start by isolating the square root. So that means I'm going to need to bring this 3 over to the other side. So undo its sign, subtract it from both sides, giving us the square root of 4x equal to x minus 3. Step 2 is to then square both sides. Now on the left side, that will leave us the square root and squared cancel each other out, leaving us with just 4x. But on the right, we've got a binomial squared. And remember that with binomials squared, you have to stretch them out to multiply them and multiply every single piece. So that will look like x squared, and it's a minus 3x plus 9. The 2 minus 3x's combined to your minus 6x in the middle. This does result in a perfect square trinomial, so if you knew that shortcut for binomial squared, definitely go ahead and use it. All right, so here we've got a quadratic equation because the highest, we have a variable with a degree of 2 on it, an exponent of 2 on it. So that means that to solve this, we're going to need to set the equation equal to 0, meaning subtract your 4x from both sides. And then you have to factor the expression you have here on the right. And so we need, this is a trinomial without a coefficient. We need factors of 9 that add up to be negative 10. So factors that multiply to 9 that add to a negative would both need to be negative. So -9 and -1 multiply to be +9 and add to be -10. So your binomials that this factors to are x minus 9 times x minus 1. From here you take each binomial separately and set each one equal to 0. So we get 1 equal to x and we get 9 equal to x. So you have to solve for x twice at the end here. So x's solutions are either 9 or 1. And at this point, you do need to check that both solutions would make sense with your answer. So if we come here with 9, let's check 9. Come way back up to the top, and we'll do 3 plus the square root of 4 times 9, and see if it equals x, which is 9. So 3 plus 4 times 9 is 36. So square root of 36 is 6. 3 plus 6 is 9. So that one works out. Let's now check it with x of 1. So I'll come over here. So 3 plus the square root of 4 times 1 equals 1. We want it to equal 1, our x. So here we're getting 3 plus the square root of 4. Square root of 4 is 2. Well, 3 plus 2 does not equal 1, so 1 is not a solution to this radical equation. Only x of 9 will be a solution. So we would have to cross out 1 as a possible solution. Only 9 will work. Here's our next example. So step 1 is to isolate your radical. That is done for us. There's nothing outside of this radical that we need to move over. And secondly, we need to now, to undo the square root, square both sides. So that should look like this. That will leave us with an x plus 1 on the left, and then you do have to stretch out this x minus 1 squared, which will give us, when you multiply it all out, an x squared. We have 2 minus x's in the middle, which combined to that minus 2x you're seeing. This trinomial over here. Now again, we've got an x squared, so we need to set this quadratic to be able to solve it equal to 0 before we factor to solve for x. So that means I'm going to subtract 1 from both sides and subtract x from both sides, giving us x squared minus 3x. 1 minus 1 is 0. To factor this one, it's a binomial, so we look for GCF first, and there is a GCF of x that can come out of both terms. So we are left with an x times x minus 3. So these are the two factors that we have, and so now take each one and set each one equal to 0 to solve for x. So x equals either 0 or 3. And at this point, you now need to check both solutions. So if x were 0, we would get 0 plus 1 under the radical is 1. Square root of 1 is 1. 1 is not equal to -1. So x will not be equal to 0. Let's see if x works when it's 3. So 3 plus 1 equals 3 minus 1. So the square root of 3 plus 1 is the square root of 4. 3 minus 1 is 2. Square root of 4 is 2. Equals 2. We're good. So x does equal 3, but does not equal 0. All right, and because the square root of a number is understood to be the absolute value of the number, a radical equation cannot equal a negative number. So let's take a look at that. So here in this problem, it looks fine from the beginning. Step 1 is to isolate the radical. So you bring your plus 12 over by undoing its operation, subtracting it from both sides. Well, that leaves you with the square root of x equal to -4. At this point, because we have an isolated radical equal to a negative, this will be no solution because the square root of a number is always understood to be the absolute value of that number, the positive version. You would really be looking for a number times itself that would equal -4. If you did -2 times -2, that's a +4. If you did 2 times 2, that's still a +4 as well. So for this scenario, you would say no solution. Here's another example. you have a radical expression set equal to a negative number, and there's really nothing. You can square both sides and solve, but at this stage right here, sorry, I'm trying to gather my thoughts. There we go. You have a radical set equal to a negative number. So right when you see that, you need to stop and state that this is no solution. So while yes, you can make this side positive by squaring both sides, at the very most basic level of this equation, we have a square root equal to a negative, which is not possible. So you would stop right there and not go any further to solve. And that would be no solution as well. So then there's some just practice problems, and what I'll do with these is let you go through by pausing and playing this video. When you see a equation at the top, you can then pause the video, work it out, and then I'll just scroll through to show you the answer when you hit play. So there's a few of these extra practice problems that you can take a moment to go through. So here's your first one. Pause the video, work it out. When you're ready to check it, click play. Okay, so we are checking. You should have gotten x to be 165. If you need to take a closer look at this work, you can pause the video. Here's your next one. Again, pause when you're ready to check, click play. Okay, so to isolate here, you subtract your 1 from both sides and then divide by 2 on both sides to get your square root of 3x minus 5 equal to 6. Square both sides and get x to be 41/3. Okay, click pause. When you're ready to check, click play. All right, so you square both sides because it's already isolated. That stretches out to this, set equal to 0, factor, and solve. The only solution that would have worked was 6. Here's your next one. Click pause. When you're ready to check, click play. All right, so isolate your radical, set it equal to subtract your 14 from both sides, and at this point you get a radical set equal to a negative number. Hopefully you saw that and did not go any further. This is no solution. There is no value for x that would make this equation true. And that is the end of our radical equations lesson.